All right, 27. Apply the second derivative test to determine the extrema of the function given the second derivative is 6x minus 9 and f of x has critical numbers of 9 and 10. All right, so what the second derivative test says is that if you know your critical numbers, and sometimes like they give you a function and you have to go and find them, so that's a whole different skill. But this one, they're just telling us these are critical numbers. So this is where the first derivative is 0 or undefined. That's what a critical number is. So if we wanted to find extrema with the first derivative test, we'd plug numbers into the first derivative and see that it's like increasing, then decreasing, or decreasing, then increasing. And if you did that, you can see it's a max or a min, right? But the second derivative test says plug them into, so not numbers around, plug the actual critical number into the second derivative. And if I plugged in 0, I get negative 9, which means this is concave down, which means that's a local max. It's at the top of that curve. And if I plugged 9 into the second derivative, this would be something positive, which means it's concave up here, which means this critical number is a local min. That's what the second derivative test tells us. Now, one of the easiest misconceptions to have, though, is if you were applying the first derivative test, you test around the critical numbers. In the second derivative test, you actually plug in the exact critical numbers, because this is when it's got a horizontal tangent line. Okay. So, hold on. I wanted to pull up something here, but okay. I don't know why that was in. Okay, so my weekly meme last week, we started talking about second derivative test. X from the first derivative is the critical points. Yes? Critical points are what you use in the second derivative test. So critical numbers are not just, critical points aren't just for the first derivative, it's also for the second derivative. Okay, is that enough for that one?